There's no answer to this question as an opinion will vary. Some people may believe that green architecture is the future due to many benefits it offers, such as being environmentally friendly and energy efficiency. Others may not think it is the future because it can be more expensive than traditional methods and may not be suitable for all types of buildings. Green architecture is designed to reduce the negativity impact of buildings on the environment and human health. The main strategies used in green architecture are to reduce the energy consumption, use environmentally friendly materials, and improve indoor air quality. By using these strategies, green architecture can help reduce the amount of greenhouse gases emitted to the atmosphere, which contribute to climate change and global warming.
My main focus of sustainable architecture is to design and construct buildings in an environmentally responsible manner. This includes using materials that are durable and have low environmental impacts, incorporating renewable energy sources, and using water and energy efficient building technologies. I think that it is possible to make green architecture sustainable in the long run in the near future. As technology improves, so is our innovation, and we might find new ways to acquire those materials or produce other environmental friendly alternatives.
Green architecture can change the way of our planet's temperature rises because it can help to reduce the amount of greenhouse gases that are released into the atmosphere. Green architecture can also help to improve the efficiency of buildings, which can reduce the amount of energy that is required to heat and to cool them. The only thing limiting construction is the lack of awareness. A green building provides all of the accommodation of a luxurious conventional home or office. However, we have always been hesitant to take a change on something about which we know a little. Green building has a learning curve, and we hope to graduate to the point where green buildings are tried and tested products soon. Green buildings are more than just a concept that can save the world. They can also make it healthier, richer, and safer. It is the time to conduct more research, and sooner we realize the benefits, the better our chances to survival as a species.
As the world's industries band together to combat climate change, architecture emerges as a standout player. This may come as a surprise, but buildings and construction account for 39% of all energy-related CO2 emissions. This provides an opportunity for green architecture to make a significant impact. In past few years, the concept of sustainability has caught the attention of many disciplines. The reason for this opportunity is the ability to carry out sustainable development. Green architecture, also known as sustainable architecture or green building, is the theory, science, and style of buildings designed and built with environmentally friendly principles in mind. Green architecture aims to reduce the amount of resources used in the building's construction, use, and operation, as well as the environmental damage caused by the emission, pollution, and waste of its components. To design, build, operate, and maintain buildings, energy, water, and new materials are used, and waste with negative health and environmental effects is generated. Green building systems must be introduced, clarified, understood, and practiced to limit these effects, then design environmentally sound and resource efficient buildings. Site planning. The site on which we can build can influence each and every aspect of the building we choose. The primary goals for green buildings in site selection are planning, site plan, site selection, site layout, reduce impervious surface of site. Number 1. Planning. A collaborative approach is followed where the owners, engineers, architects, contractor, and important stakeholders to work together to develop a sustainable design process. This helps to combine valuable inputs from different expertise. Number 2. Site plan. Following the meetings and inputs, a long-term site plan is created. A sustainable site plan of green building construction is one that has a low environmental impact while meeting the client's project goals. The site plan must adhere to the project parameters while not jeopardizing environmental concerns. Number 3. Site selection. The location must not be in a disaster zone. Floodplains should be avoided. If the building is to be built near water, buffers of undisturbed soil must be provided. The ease of transportation of resources for construction must be considered. The location is convenient for public transportation and other modes of transportation. Make sure that basic amenities like a bank, childcare, a post office, a park, a library, a primary school, a clinic, and a community hall are close to or on the site. Site layout. Proper building orientation or site layout can save up to 25% on energy. The following parameters are taken into account when building siting and orientation. Number 1. The plan is elongated along east-west axis. Number 2. Exposures to north and south are good for daylighting. Number 3. Windows must not be provided facing east and west. And number 4. The most populated area must be oriented towards the north or south direction. Number 5. Reduce impervious surface of site. Using a large amount of impervious surface throughout the site to avoid water runoff issues and to improve the aesthetic is not a sustainable practice. Increased impervious surface affects the groundwater recharge, resulting in the heat island effect. Reduce impervious surface of site. Using a large amount of impervious surface throughout the site to avoid water runoff issues and to improve the aesthetic is not a sustainable practice. Increased impervious surface affects the groundwater recharge, resulting in the heat island effect. Limiting the impervious surface area significantly reduces the environmental impact. The following methods can be used to reduce site imperviousness. Number 1. Implementing green roofs. Number 2. Placing plants around the parking area. And number 3. Implementing permeable pavement operations. Water management. Water is the most critical resource, and all human activities rely on it. Water is used to drink, as a process in industries, to support wildlife, generate electricity, and cultivate crops. As a result, water is referred to as the elixir of life. Water has been most exploited due to its relative abundance and inefficient use in industry. This so-called abundance is an illusion that encourages wasteful water use, ultimately leading to water scarcity in our country. Green buildings are sustainable structures that require water conservation, pollution prevention, and the use of gray water and recycled treated water while ensuring potable water is used only for potable purposes. The fundamental principle of green building is water conservation. An effort should be made to ensure that the materials and systems used to contribute to reduced water consumption in buildings. The principle of sustainable water management can be achieved by using an alternate source of water that can be supplied to meet water demand where the water quality does not have to be potable. Rainwater harvesting is a technology that collects and uses rainwater from individual buildings or groups of buildings during the rainy season. This water can be stored in tanks and used for purposes other than domestic. Although most technologies are focused on making greener buildings, new investments are constantly being developed to assist both organizations and homeowners in reducing waste environmental degradation, and pollution. Although most technologies are focused on making greener buildings, new advancements are constantly being developed to assist both organizations and homeowners in reducing waste, environmental degradation, and pollution, resulting in impressive economic, social, and environmental benefits. Rainwater harvesting is one of the best examples of green building particle. Rainwater harvesting is one of the best examples of green building practices. Rainwater harvesting is probably one of the best ideas for making use of natural rainwater that would otherwise go to waste. Rainwater that falls is lost forever, especially in areas densely packed with concrete buildings. That is why even the smallest building should have a rainwater harvesting system in place to provide a consistent source of water that can be filtered and refiltered to make it potable for human consumption. Aside from being used in restrooms and water gardens, harvested rainwater can be purified using simple techniques to make it safe to drink. Rainwater harvesting has the advantage of being able to be done on both a small and large scale, with several thousand liters of water harvested. Energy. The future of ecological sustainability in built environments is dependent on the thoughtful deployment of eco-friendly and smart energy management technologies. This entails utilizing cutting-edge technology such as the Internet of Things to reduce environmental impact by assisting in the identification and reduction of water, increasing efficiency while simultaneously improving safety, comfort, and security. Internet-connected devices such as smart sensors, lock, speakers, thermostats, or smoke detectors share data with a certain system, which collects and uses it to highlight issues and suggest areas for ongoing improvement. Building owners or occupants can customize these integrated systems, which can then operate without human intervention to optimize energy efficiency in green buildings using artificial intelligence. Installing smart technology to monitor a building's environment does not always imply significant additional costs. In fact, deploying an analytics-driven building management system to improve energy efficiency in green buildings can reduce the cost of maintenance over time. When basic maintenance is supported by network-connected devices and smart building systems, greater efficiency can be achieved without requiring a great deal of investment. Examples: lighting. Reduce energy consumption in green buildings by installing more efficient lighting, such as exterior solar-powered lighting or LED light bulbs. Dimming or turning off lights automatically when natural light is sufficient or when building occupancy is low helps to reduce energy consumption. Heating water. Water heating is another significant source of energy consumption, particularly in residential buildings. Energy consumption can be reduced without affecting users by adding insulation around water heating systems and installing sensors to control the heating mechanism. Connecting this to a central smart system that collects usage data can also identify times when hot water use is high, aiding in the detection of leaks. Exterior and roofing. Exteriors and roofing areas are frequently sources of energy loss. They should be closely monitored, especially in climates with extreme temperatures and weather. Sensor data analysis can help identify energy waste points to justify upgrades to more energy-efficient roofing materials or direct cleanup efforts as needed. Basic maintenance measures to make exterior greener. Number 1. Clear debris from flat roofs to reduce standing water and prevent deterioration. Number 2. Ensure maintenance personnel use environmentally friendly cleaning products. Number 3. For slope roofs, ensure gutters are not blocked. Number 4. Remove mildew or mold residue on siding and windows with non-toxic cleaning agents rather than replacing them. Number 5. Replace or seal damaged roofing before winter, particularly for flat roofs to protect against leaks. Number 4. Replace, seal or caulk windows and other openings to reduce energy consumption. Number 7. Use sealants approved by rating systems like Leadership in Energy and Environmental Design. Roofs and sun-facing surfaces are also good spots for installing solar panels, and smart devices incorporated into buildings' exteriors can help maximize energy production. Sensors can also determine temperature differentials to identify areas where inadequate insulation or leaking systems contribute to energy waste. Number 4. Integrating Internet of Things technology. The Internet of Things is a transformative and ever-evolving technology that promotes the connectivity of all devices to networks. When deployed in a building, IoT can assist your operations team in reducing energy consumption and improving building occupant comfort because network connectivity makes data from IoT sensors available to humans and machines for analysis and troubleshooting. Master System Integrators, or MSI, are essential in ensuring that building owners reap the benefits of these technologies. They can deploy advanced software layers with deep domain expertise to integrate communicating devices, systems, or third-party applications into a unified front end with intuitive user interfaces that make it simple for all types of users to manage, monitor, and maintain their green buildings. Buildings IoT software and services improve green building efficiency, extend the life of your building assets, and improve occupant experiences. Famous green architects. Jean Nouvel. This French architect has won several major awards for architectural design, such as the Pritzker Architecture Prize in 2008 and the Aga Khan Award for Architecture. Jean Nouvel designed the Arab World Institute in Paris, the Guthrie Theatre in Minneapolis, and the Terra Agram in Barcelona. One of the best examples of his work in sustainability is the Dentsu building in Tokyo. Some of the sustainable projects has her worked on recently include the tallest vertical garden in Sydney, a nature-filled national art museum in China, and coal gasometers transformed into urban living in Vienna. Number 2. William McDonnell. This American architect has more awards than he can count. They include the EPA Presidential Green Chemistry Challenge Award, the Presidential Award for Sustainable Development, and the National Design Award. William McDonnell designed the Ford Rock Truck plant in Michigan that has an innovative air delivery system to reduce ductwork, as well as the Adam Joseph Lewis Center for Environmental Studies that produces 30% of its own energy at Oberlin College. Additionally, McDonnell is a co-founder of the Make It Right Foundation. Ken Yang. This Malaysian architect focuses his career on designing sustainable structures that were on with nature. He created the bioclimatic skyscraper that has shaped the way that architects design skyscrapers around the world. Essentially, he uses the surrounding environment and vegetation to drive this design instead of competing with it. Ken Yang also believes that structures must have beauty or they face rejection. In addition to his architectural designs, Yang has published books on ecological design and won several awards. Glenn Murcutt. This Australian architect has been working on modernist buildings since the mid-70s. He likes to position buildings so that they absorb the most sun and have good airflow. That's why all of Glenn Murcutt's designs are open concept. He is one of Australia's most famous architects and has won several awards, including Pritzker. Murcutt mostly works on homes, but he also designs the Arthur and Yvonne Boyne Education Center. Renzo Piano. This Italian architect is arguably the most influential green architect in modern history. He doesn't stick to stereotypical sustainable building shapes or materials, but he still incorporates elements that are green in his design. One of Renzo Piano's famous designs are the California Academy of Sciences, where a museum houses an aquarium and planetarium. The real show-stopping component, however, is that Piano built it into the side of a hill, so it really blends into its environment. The building needs no air conditioning, and it actually absorbs 2 million gallons of rainwater every year. Piano also worked on the Stavros Niarchos Foundation Cultural Center in Greece. Rolf Disk. This German architect's design focused on incorporating the power of the sun. Since solar energy costs are not as high as they once were, Rolf Disk takes full advantage of solar to make his architectural design sustainable. He is most famous for the heliotrope, a residence that he constructed for himself that harnesses the optimal level of natural sunlight to warm water and generate electricity.
Ay, hindi natin makita yung sarili natin eh. Basta nandito na lang ang The Boys. House tour. Tara guys! House tour. Nakikita nyo po si Silver. Pure Silver.
Wala. Wala. I-sensor niya yan.
Ito po ang Hacienda del Carmen.
Tapos ito po yung, kung nakikita niyo po yung dati kong mga classmates sa 204. Dito
Ay, dito
po
ako nakakita.
Dito po yung...
Ito na.
Oo, dito.
Lagi ka nakaganon.
Nakaganon din ako.
Kaya po, may stiffneck akong gano'n.
Oo eh. Ito po yung may-ari ng Hacienda del Carmen.
Ano ko? Drafts ni Tepo ko po.
Ang
Kaya
opisina.
pala, may nakakabak.
Ayan po, papalakas ng damdamin.
The motivation.
The motivation. Ayan.
You can do it, baby.
You can do it. Tapos ito po, ayan. Tech pen. Pag
Ayan
nalagyan
The Boys.
Grabe na yung tech pen.
Magkano ba yung sa ganito?
Featuring Pops Rowie,
Champion o
Art,
tao. Ano talaga siya?
Gumagawa.
pangalan nito,
Kami, kasama na ilaw.
Ralph, and JJ. Ay, ito yung...
Sa amin yung...
Pati yung ilaw?
Yung may ganito din, kaso walang ilaw.
Ito nga,
Ayun,
Pero
pwede na yun.
ito nga yung ginawa natin. Ito yung ginawa namin sa interiors. Ito yung redesign namin.
Thank you. Tapos, good
Nakikita nyo naman ng tatlong perlas na kumikinaw sa taas.
Ha?
That's what you call
Vegan.
expensive.
Hindi. Hindi.
Ano lagi mo lang?
Nilagay ko lang. Sakto-sakto lang.
Ang kwarto ni ni Mayor Nat, the gaming set. Hell yeah.
Yun, no?
Ba't yung pinasa-plate na yan?
Ha?
Oo, dati na yan.
Dati na.
Ang 100k worth of bike.
May natutulog.
Tsaka yung reporter nyo, oops, pasilip lang yun.